already familiar with Kafka? Okay. Who's familiar with event sourcing as a pattern? Okay, good. We have the right audience. So, let me start with a brief introduction first. So my name is Pavan Keshavamurthy. I'm also one of the co-organizers of this meetup. But outside of this, I run a small consulting firm called Platformatory. I'm obviously from Bangalore as well. I contribute to half a dozen different open source projects, but amongst them, primarily there is Kong as well, but I also contribute to Envoy, some part of the Apache Kafka ecosystem, amongst other things. So let's go over to today's session. So here's what we're going to talk about, right? So everybody is here for the Kong meetup. So Kong is obviously the best API gateway in town. I think Abhishek spoke laurels to Kong's capabilities. Sub-second API latency is probably the best in business. For those who have used other API gateways back in the past, you might have seen just API proxy bound latencies of 30-40 milliseconds and above. Okay, so if you come to Kong is a world of difference. Okay, that's primarily because of LuaJIT and all these underlying technologies that make Kong so efficient. So it's blazing fast. Obviously, you're therefore using it to secure your APIs and run a facade right at the edge of your APIs. Also comes with an integrated service mesh, and the Kong is seeing huge adoption globally, right? To the extent that I'm seeing many large banks which wouldn't touch open source with a barge pole as recently as 5-10 years ago, now actively being Kong adopters, and some even being Kong contributors. Obviously, CRED is also an example, I guess, of a digital native that's also using Kong at scale. But today's talk also features Apache Kafka, a very similar, very mature technology. So there are some people in the audience who are already familiar with Kafka, but for those who are uninitiated, Kafka is basically a distributed, partitioned, ordered commit log. A lot of people often describe Kafka as an MQ. It isn't. So Kafka's main use cases are around streaming. It's a system where you could basically emit events with publish-subscribe semantics, and in that sense, it's probably similar to Amazon SNS or GCP pubs, amongst other things. But Kafka is different because it also has storage as a first-class capability, and therefore that makes Kafka extremely useful for a lot of scenarios, everything from big data analytics to just building event stores and full-on stream processing applications, amongst half a dozen other use cases. So Kafka is, unlike Kong, is a TCP wire protocol based application. Therefore, its wire protocol is also what has become the de facto standard of how you do eventing. So that means it's not just Kafka that we're talking about. It could just be Azure Event Hubs. It could be AWS MSK or somebody's own sort of custom flavor of Kafka, as there are emerging. There is, I don't know, some of you in the audience might have heard of Red Panda or Apache Pulsar. These are also Kafka compatible. So in general, what problems do these things solve for? They basically solve for essentially modeling what is happening within your application as a sequence of events, right? And storing them, persisting them, such that they can be ordered and therefore be retrieved and processed in that order with a set of acknowledgements. All of these features are the building blocks of how one would implement an event-driven architecture. So Kafka is also an open source project. It was born out of LinkedIn, but it's being used by about 80% of Fortune 2000 companies. So in general, we're talking about two extremely useful technologies that have wide adoption in the enterprise. And today, what we want to talk about is how the intersection of these two things will be interesting for somebody who's got an architecture lens on, right? How do you progress from just doing APIs you're probably using Kong to secure your APIs. Now, how you can go a step beyond towards turning your API gateway into an event source and therefore progressing towards an event-driven architecture. That's the theme of this talk. And just to put it in perspective, for those who may not have immediate background on what event-driven architecture really means and in the nuts and bolts level, event sourcing, or a very familiar pattern around event sourcing, which is known as command query responsibility segregation, primarily arises out of the fact that systems grow, and when they grow very large, scaling is a pain, right? And when scaling is a pain, you want to break that problem down into what part of scaling is hard. Is it about scaling a massive number of writes into the application, or is it about scaling a massive number of reads into the application? Obviously, scaling reads and serving up reads is an easier problem than serving up writes. But to do them consistently and synchronously has been the bane of architecture for a long time, right? And that's kind of where event-driven architecture has really evolved. That's the milieu. So it's that any application or any state change to a particular object or entity within your system can be captured as a bunch of events and therefore applied in an eventually consistent manner. That's the general basis of how this works. So think about an e-commerce scenario. You have orders and you need to scale orders, right? So as soon as an order comes in, you probably need to go put the order into your shipping system. You probably need to go reconcile payments around the order, whether the payment really happened or not. And you probably need to go take the fact that the order occurred, right, that event, and probably put it into a big data analytics system, or go, throw off an alert to, 20 different people who need to be notified that the order just came in. And of course, doing all of this synchronously is hard, right? That's sort of where eventual consistency and putting a layer like Kafka, which acts as a buffer zone between the event actually happening and all the downstream reactions that need to happen because of that event happening, and that's sort of where this architecture really comes and plays in. So in the most fundamental sense, you might have a /orders endpoint. So you post to /orders, it creates an order, right? Now, how do you distribute the fact that this order happened to probably 20 other parties that are interested in that event, right? So one way to do it is to go tell the team that manages the orders application or orders microservice, tell them, what, you need to now publish it to Kafka, or you need to publish it to some other system, right? And that's great. If you can do that, that's absolutely the most preferred approach. But we live in an imperfect world, okay? Particularly those who might have enterprise experience might be aware of the level of dysfunction that exists in large companies, surely because of their size. So sometimes you don't have control on some other team or what they do. They might not be willing to do it. Maybe it's a legacy system, it's broken, and you don't want to really touch it right now. So in such cases, let's assume that you still have the API gateway, which is a layer over all your APIs. How do you pick up the fact that such a command occurred? Okay, so the command here in this case is think very naively, it's a post or a put that's basically changing the state of something that is saved in your database. Now, you are actually able to intercept that at the API gateway level. Right? Your API gateway knows about it before it's being relayed to your backend. So, strictly speaking, you could actually turn your API gateway into an event source. The fact that something occurred, and instead of having your application team do it, you could actually source that event directly from the gateway. And as a result of that, how do you serve up a read optimized model of the order or do 100 different things that need to be downstream effects is something that is up to you. It's a much more trivial problem to solve, especially when you put up a buffer like Kafka in between. Yeah, so let me know if there are any questions so far, but this is the general background to this talk on what why eventing is required, right, and where eventual consistency comes in, and particularly what CQRS is about. CQRS, just to take the jargon out of it, is basically about solving for reads and writes separately with different models being involved. So, we'll follow this up with a quick plugin demo on what you could do with Kong and Kafka. But the drivers are obviously one. Particularly, there are legacy APIs. You can turn those into event sources with zero code changes. That's the first and most important driver. And that's relevant not so much for a GET request where you're reading something, but particularly relevant for commands when you're changing something, right? With this, you can also obviously enable event flows with massive scale fan out. What does that mean? Order got created, where 30 different parties are interested in it. Instead of trying to shove all that orchestration logic into your orders app, what you could do is you could basically write it, produce it to something like Kafka, and then allow multiple subscribers to pick it up, process it. So it's a little bit of write once, read many times. Lastly, none of these things are actually being done in a vacuum. There are these are pretty much the building blocks of modern architecture, and to that extent, on how cloud services actually publish events. For example, something coming into your S3 bucket is an event, right? So all of these things are actually being aggregated, if you could say that, into a format, right, which becomes sort of how cloud native applications would generally publish events. And that's what cloud events is about. Cloud events, unlike just REST APIs, can have multiple protocol bindings, not just be published through HTTP, but in a variety of other ways. So what we're going to walk through today will also demonstrate that to some extent. Lastly, my best summary of what you're going to see right now is to think about change data capture. Who's familiar with CDC, change data capture, division? Okay, there are some people in the room. All right, so what is CDC about? CDCs are primarily about subscribing to the write-ahead log of the database, right? When you use a SQL database, it could be MySQL or Postgres, before it actually writes anything to a disk, before your transaction is committed, it's actually first written into a write-ahead log, right? So therefore, it's actually possible for you to pick up row-level changes. For example, give me data as soon as it comes into this table. That's something that you can do out of a database. However, the problem with that is that often the data model of the application that you are building does not map one-to-one with database tables, right? In any modern framework, you have object relational mappers, you have normalized schemas and things of that sort. So you may have just your ID in a table and the rest of the data probably coming from a different dimension. So all those possibilities exist. Therefore, CDC is not always a viable option, and that is where an API gateway in which all your API traffic is passing through, and therefore it's obviously built from the point of view of an API consumer. So being able to pick up the event and relay it to something like Kafka would make a lot of sense. Illustratively, this is what we'll try and demo today. So we will make a post call or a put call to a hypothetical order service, okay, which is obviously going through the Kong gateway. It has a route through Kong. We will configure the Kong event sourcing plugin out there. It will be configured globally. And what we shall see as a result is with no changes to your application, but with basically some Kong configuration, you're going to take the response of a post/order and relay it to an order created topic in Kafka. And just for vanity, we'll do a couple of silly demos, right, where the order created event is picked up and is emailed to you and also put into some kind of an analytics database or something of that sort. So we'll just see how this whole thing happens. Let me know if there are any questions so far, otherwise we'll skip straight ahead to the demo and we'll try and restrict it to around 5 minutes. Questions?
So gateway will capture all the events.
Yes.
It will store also.
Yes. Kafka will store it.
No, not Kafka. Gateway. How will you read from the gateway?
How we will read from the
Gateway.
From the gateway. So we'll put in a custom plugin there, which reads this thing outside of the request path in the log phase, right, and send it to Kafka.
Yeah.
Sorry, I had to restart, so we'll have to do this all over again. This is the plugin. So it's published on GitHub, and you can also install it and try it out with LuaRocks. We'll briefly go over how the plugin is configured and how it actually works. Okay, so this is my Kong declarative configuration. Yeah, sorry. All right. So we have a hypothetical order service which is just pointing to HTTP bin, but it has a route which is /order. All right. So what we're doing with this is we're configuring a plugin globally, right? Which is our plugin. This is the Kong Event Publisher plugin. And what we're doing with this is we're going to use Confluent Cloud, which is a managed service for Apache Kafka, but you could do any other Apache Kafka service or your own if you would please. Also, just a note, this plugin also supports secure authentication to Kong. There is an open source Kafka log plugin, but that does not support authentication just as yet. So we configure the Kafka servers. That's basically what Bootstrap servers is about. Port and Kafka supports multiple security mechanisms. In here, what we are actually doing is we are authenticating to Kafka through plain. Plain is not plain text. Plain is a username password form of authentication to Kafka. It's the SASL family of authentication, which is a popular Java framework. You can also configure what's the encoding of the event that you relay to Kafka. This can be encoded in multiple ways. It could be protocol buffers, gRPC, or it could be Apache Avro, etc. For this example, we are going to do just plain JSON. There is also a specific format in which the message is composed, and in this case, that is the Cloud Events Kafka protocol. Right? That's what we are going to use. That's what this plugin supports right now. The real core of the plugin configuration is here in the event maps. So what we are essentially declaring out here is that if the request path matches /order at position 0, where is the resource expected, and if the HTTP method is post, right, and if the response codes are any of 200 or 201, then relay the payload of the response to the order created topic, and it also substitutes some Lua load string based substitutions of tokens. So I can add the key as the Kong route and the data as the entire Kong response body. And that's it. I can configure multiple such routes out here, right? So obviously how you do this is based on how many APIs are actually passing through Kong. That's basically it. Now there may be certain scenarios in which we pick up a command for which we don't know what is the corresponding event, which is it order created, or is it order updated, or is it something else. So in such a case, which Kafka topic would the message end up in is questionable. So therefore we want to have a margin of safety. So therefore we also have a dead letter channel. Like if we didn't match it to anything else, where would it go? It would go to a dead letter channel. And that's pretty much it. So let's get this up and running. Sorry folks, I'm on mobile internet. It's terribly slow. You know what? We'll just do this to the CLI. So I have a Kafka cluster up and running out here. What we'll do right now is we will make a couple of requests, okay, and see how the data actually lands up in the order created and the order updated topics respectively. So you can see the topics themselves out here. So if I go to topics, I have 3 topics set up. Order created, order updated, and a dead letter channel topic. So now let's go out here and run a couple of requests.
Could you zoom in a bit?
Sure.
Yeah.
Just have a regular old shell script to send a post to the /order route that we created, and you can actually see here in the Kong logs that it's actually sent the thing to Confluent Cloud to the Kafka topic that we configured. Let's also do a similar one maybe for order update. Okay, that's good as well. So that's it. So what we shall do right now is to consume these events, and I'm just sequencing these out, but typically these are actually happening all real time as well. So the delay between a request into your gateway towards that being published through Kafka to all the consuming applications is usually sub-second, right? So let's consume these events, and I should hopefully expect to get an email and see the same data being updated in a database. All again done without any application code changes. And so let's see that quickly. This thing is going to basically send an email to me very trivial. Okay, I should have hopefully received an email. And on the right side, we'll basically pick the event up from Kafka and write it to our database. Sure enough, I have an email. Right, this is basically the same request that was made. It's got a bunch of all the request response route and all the accompanying context. This payload is also in the cloud events format. So therefore, you could use a regular old Golang, Python. There are SDKs for practically all languages to pick up and process the cloud event if you would prefer to do that. Now, similarly, we should also see this thing in the database on the other side. See, there's an order created topic. Sure enough, it's the same timestamp. So whatever was emailed is also out here in the database. So that pretty much concludes the demo. I shall not keep everybody. We're a little over time already. Keep waiting people. Keep people waiting. But what are the larger implications of this, right? So the main thing is it's about integration primarily, right? You know, you have one thing happening, you want to inform other systems. That's one of the primary use cases. So if you want to progressively move towards an event-driven architecture where you can't basically muck with the application directly, this is one way to do it. The other thing is possibly data integration. You want to take some data and feed all your API logs in a meaningful manner to the analytics plane where you want to do some big data analytics. That's another use case. Apart from this, you could also just use it for general integration, right? So application integration, data integration, and analytics, possibly. So those are the things that you really want to see. You can pick up the plugin, and you can also use it, install it with Lua Rocks. So that it's out here on Platformatory/Kong Event Hub on GitHub. Yeah, please let me know if there are any questions. Thank you very much. Please go ahead.
From a lifecycle standpoint, will this plugin sit in a hot path for all the requests coming in, or how would it work?
Sorry, I can't hear you.
From a lifecycle standpoint, will this plugin sit in a hot path of the
Yes. The good part is that so therefore it should not really have any performance. Also, it actually is distanced from the Nginx master process itself. So what happens, this is a technical detail of the implementation. What happens is that the Kafka produce request is actually done with the Nginx zero delay timer. It's kind of handed off back to Nginx, where Nginx will basically manage how and when this produce is managed. So it shouldn't adversely impact your Kong data.
use cases that differ based on consistency? Events like
You'll probably have to change the way acknowledgements work when you publish messages to producers, right? In Kafka. So does that?
It's a synchronous producer.
Right. So would the plugin could potentially cause impacts there? Let's say if production to Kafka, for instance, takes a second. Just taking an example.
Are you saying? Maybe you might want to restate your question.
Yeah. I was trying to understand. So let's say Kafka, when you publish to it, there could be multiple acknowledgements or guarantees to publishing. For instance, you require high consistency. In that case, the delays with respect to latencies will be really high. So what I wanted to understand is, let's say it crosses a second, for instance. Is it correct to say that it won't really affect the response times?
It will not affect your gateway response times for sure, but
Respective APIs?
not with respect to your APIs. You may have potentially some Kong level side effects.
Yeah.
Particularly in edge cases where your brokers are unavailable and your producer is retrying in a loop because it must complete the request.
Got it.
But that's going to keep one of your Nginx worker threads hanging.
Sure.
But that's as much as the adverse impact. It shouldn't affect your APIs in themselves.
Sure. Got it.
Anybody else?
But in that case, how do you resolve them? That is the business case to be resolved or?
Sorry?
The same scenario. But how you handle it? Because my worker threads are hanging.
Right.
How you resolve them?
I mean, it would be like any other problem, right? If you have a system that's running amok and it needs to, eventually kill itself if it's not happening. I mean, more important is to understand in what scenarios would such a situation happen. In scenarios, you have a network problem from where your Kong interface to
How the
Kafka.
business logic?
What specifically do you mean by business logic?
And how you handle that flow? Kafka ordering and then how you receiving the response time and everything that you are how is it go release the application.
Okay. I don't completely understand the question, I'm afraid.
Same question here.
Okay, same question.
Same question how you solve it. Because my worker thread will be hanging, will not give you response. It's my lot of same type of response.
No, I mean that's not true, right? I mean, if your worker thread is hanging, it's not that the response does not go out. In fact, all of this stuff happens after the response has gone out to the API client.
That from the end user perspective, fine. Behind the perspective.
Okay, right. I mean, my answer to that mainly would be to set your retry budgets, right? Such that, something does not hold resources for way more than necessary. So obviously, you need to have some monitoring around it as well.
Because my continuously worker thread will go hanging.
Yeah.
Then if that worker thread will use the resources on that, then allocate.
Correct. I mean, the main thing is to obviously have a retry budget. Okay. If it fails more than 10 times, then back off. Have an exponential backup or something of that sort. And secondly, having some observability and monitoring, such that you monitor for things that are hanging and trying to do a Kafka produce request while not doing anything. Those two things. What does?
What is the rate for it? Is the failure or configuration of a post response everyone configures?
Correct.
So it's like if I have 100 posts, then I have to configure 2. So 2 would go in my order catering, rest 90 would go to 2.
Correct. I mean, basically it's a dustbin. If it didn't match anything else, you don't want to lose it. You might want to figure out, which of those events got orphaned. Maybe have a separate process to come back and reprocess it, etc. So in such a case, you don't want to lose the data. Maybe eventually you'll set up a topic or some other specific process for it over time. But in the interim, DLQ is a way to monitor. I mean, is there stuff that I'm losing, right? So it's mainly for that purpose.
When you need to provision for that also, right? Any extra burden that you're putting because of DLQ?
I don't think there's any extra burden because of the DLQ. Correct. I mean, that's up to you in terms of configuration. The DLQ is meant to be used only for things that you actually want. If you don't actually want something at all, you should probably configure the plugin only on the routes where you actually expect to intercept events, not on the ones where you don't expect to. See, here, only for the sake of a demo, we configured it globally. Otherwise, you would normally target it to specific services or specific routes. And even there, you would give an event map of only the things that you are interested in.
So we talked about the choreography. So for the choreography to be like, how do you guarantee ordering this and this so that like if it's only for an analytics purpose or it's made up, then you don't need to work around that. But is there any other semantic that you added for that?
It's mainly the resource path, right? So for example, if it's an order, right, you want to basically maintain order, you want to maintain ordering, okay, sorry for the pun, but you want to maintain ordering of all events for the /order resource. So therefore, in Kafka, ordering is based on partitions, and partitioning basically happens based on what key you use, right? Your key is basically hashed into a partition.
So right now, the key used was the
/order.
/order.
Yes. It could actually be, if there was a specific order object, maybe you're trying to do order / some order ID.
Yeah, multiple services and multiple keys and multiple partitions.
Correct. That's right. So the ordering will be maintained by the resource. So it's guaranteed to be in order. For example, if you do a post and put in sequentially, they will end up necessarily in that order. As long as you do a synchronous producer.
That's what I'm saying.
It's a synchronous producer.
So you're not. So what I mean is when I do those kind of things.
Absolutely. I mean, for those sorts of cases, we would actually want to batch it out. What you would want to do is you would want to actually take these and maybe stash it on the Kong worker somewhere and then batch it over time and then produce it. Here we are using a synchronous producer, mainly because it's good for demos. But you can configure it. That's right. Anybody else?
But the custom plugin, which language is it?
It's written in Lua. Lua has relatively poor support. There are no good Kafka clients. There's only one that I found. So this is almost half written from scratch. There is an old Lua REST client, but there are very few others. Also in terms of encoding, etc., I only know of one abandoned project which does Avro encoding. So yeah, I mean, Lua has its benefits, but it's also extremely minimalistic.
But use the JSON only is good, right?
Yes.
Not Avro?
We have Avro support coming up next. Okay, thank you very much. We shall break for lunch.